about the presentation.
That were good.
Okay. So welcome, ladies and gentlemen. My name is Florian Hönicke, and I tell you today something about our beloved framework. Oh, there's still coming some people in. Hello, Richard, for joining as well. I will talk about Jina AI, our beloved neural search framework from a solution engineering perspective. And first, I have a small question for the audience. Why does, I hope I don't mess this up, feel amazed by rhymes with Jina AI? It's a vowel rhyme. If you don't think it rhymes, it's not bad. It just means you're not a rapper. So you're listening to me, Florian Hönicke. I worked at, still people coming in, nice. I worked at Axel-Springer, Deloitte, Soundcloud, and over the time I worked on more and more search-related stuff. So developed a rhyming engine, who would have known? And also then founded a startup focusing on neural search, and especially in the domain of image for model agencies to let them easily find all the talents for certain roles. And yeah, when looking at all these search-related topics, what could be possibly the logical next step? Of course, this is my first day at Jina AI. I like looking at these photos from time to time, and it was a very exciting day. Got to know many new friends. And what I really loved about this company, like everything is open source. And also neural search is actually a thing these days. So being part of this makes me feel good. But yeah, let's get to some content. So I will first start with talking a bit about traditional search, then give an overview over neural search, aka Jina AI. Then I will talk about the real-world examples we built with this, because just working on a framework doesn't bring you anywhere. To develop this framework in the right direction, you must build real-world cases. And at the end, there will be a happy cat picture, so stay tuned. So this is the slogan from our website. Jina, an easier way to build neural search on the cloud. So let's put this sentence apart. So we have easier, which means in our case, like you could build neural search on the cloud yourself, but you will spend so much time with actually building everything around the infrastructure, making it scalable, and so on, so that you cannot really focus on your certain solution, your search case you want to solve. So Jina provides a framework which takes all this work away from you and lets you focus on your search problem. And then the second thing here is neural search. And this is something we have to talk about, what neural search is. But before we talk about neural search, maybe it's good to go one step back and look how traditional search works. And maybe first let's stop the flickering because it's annoying. Okay. And yeah, we have TF-IDF, the term frequency inverse document frequency, which is also beloved as a traditional method to rank documents stemming, like take the word traditional, maybe there is tradition in the text and your search term is traditional, but to find the word tradition, you can stem the word, bring to the word-to-word stem, and then search for a tradition and get your search results. So all these handcrafted features, stop word removal, regular expression, knowledge graphs, where you put in all your expert knowledge and run your search queries. Takes a lot of effort to put in all this information, and therefore it is also limited in the amount of queries you can run against this. And also symbolic regression, which I would like to go really deep into. Oh, sorry. So, which I would, okay. Seems like my computer thinks these methods are either limited or not generalizable. So let's go for a more sophisticated approach and use neurosearch instead. So neurosearch comes with advantages. I mean, very, very convincing advantages. And as always, of course, also some disadvantages. And let's talk about the advantages. We have cross-modal search, a multimodal search. So modalities can be different kind of data, and you can go from like image to audio. I will talk about this in a second. Then your model can really grasp the semantic meaning of the data if it's trained in a right way. And yeah, then these neural search methods are much more generalizable. So you don't have to build up a new knowledge graph each time you decide for a new use case, and you can reuse much more. And of course, it comes with disadvantages, like you have more computational expenses, but in the age of very cheap GPUs, this becomes less and less of a problem, except when looking at training models, they seem to cost more and more because they become something like space stations, which are built once and then can be used by everyone. And this is exactly what we use at Jina, these pre-trained models. And yeah, also like this is a black box. So neurosearch, you might have guessed it already. At the end, it's a neural network, and you don't really know what it can come up with next. So common solutions for this is to have always these neural network searches guided with traditional methods to keep the AI in some bounds. So let's talk about cross-modal, multimodal. So we are used to enter a search query in text form and then get some results, but that's not all. You could think of inserting an image and then getting some audio, inserting a movie and getting some text as result, for instance. And even 3D objects, you could search for a certain 3D object in a database of movies and then find movies where these 3D objects is contained. And so that is totally made up, but just to show you, so this is not made up. Collaborative filtering is actually a thing where you embed user data and product data into the same latent space, and then can, for instance, find all the relevant products for a user, but also all the relevant users for a certain product, stuff like this. Also, you can think of things which are actually beneficial for society, some drug research, search on protein databases to find similar protein structures which act the same way. I've no clue, but just to open your mind, it could be anything. And this means, yeah, multimodal. Here, just a simple text example. We know this from Google. When we type in some text, then we get images. But let's now focus from the model perspective and appreciate if it's not getting any more text there related to the images. Like this is our multimodal example. We have, we implemented the clip model there. And it seems to really have an understanding what this living in a simulation could be related to. Of course, some like obvious examples. The one in the bottom right corner looks quite interesting to me, that this model thinks like this is a good illustration of like machines and humans work together. I think I was impressed by this result. And later I will show you how you can use Jina to try out these toy examples, actually, these Hello World examples. So let's go to the next one. Yeah, just to underline the semantic search a bit more. Here I give in another modality, like I give the image as query and get related results. And interestingly, the model doesn't focus on low-level features of this image. Like almost, like not many low-level features are matching, of course, some hair and so on. But it seems to somehow understand that this is a yoga or meditation position, and then gives related images based on this. You can also try out this example later on your own locally. So I hope I made you curious now of how neurosearch actually works. And I can explain it to you. So to me, like the most simple definition of neurosearch would be, it's a pre-trained model and some low-dimensional intuition of what to do with this model. Let's go into the first part first. So there's something all of us probably know. We input some image data, like here in this example, some cats, some dogs, and have a supervised training methods where we provide the labels and train our network. So training, check. Then we remove the last layer. That's a classification layer. And what we hope here is that we're now feeding some, so after training, of course, after training, we feed some images into the network that instead of just getting the label, it's a cat or a dog, in these a bit lower level, but still high level layer here, that we get some meaningful vector representation of the object scene, and that it's something we can generalize maybe also to other animals, because in this layer, what's probably in there is something like okay, let's actually start with the first layers. Like the first layers here will have some edges, and then maybe here's a cat nose or some hair structure or so, and then here are actually ears and so on. And these ears or the position of this animal and so on, they can be actually quite useful to also make neurosearch with other animals. But we train just on cats and dogs. How awesome is this? And have in mind that we just talked about images now, but all the other modalities can be as input as well here. So this is just an example for doing this with image. So the whole thing here is now called an encoder. And we use this terminology now. Pre-trained model check. We have our encoders. So what actually to do with these features we get here? Just for the terminology, so this can be called feature extraction, the vectors we get out of here. It can also be called latent space vectors. So there are a lot of encodings, simply vectors. So there are a lot of words which basically all mean the same. So let's build up some low-dimensional intuition about what to do with these embeddings. So we have our data points here in a two-dimensional space. This is much better for us to imagine than like this 1, 2, 3, 4, 5, 6-dimensional space. So we use our two-dimensional intuition we have here to describe something which is actually 6-dimensional, but yeah, the same rules of two dots are close to each other, distance calculation, they can also be applied to a higher dimensional space, no problem. So just to remember what we're doing here. So we insert some images, get vector representations, and we put them into this graphic here. So, and we assume it would be just 2 outputs here, but it's actually 6, but we cannot visualize 6 dimensions. So we visualize it on a 2-dimensional plane. And yeah, what you can see immediately, like these cats seem to have a very close distance. Of course, because they are cats, they are more similar to each other, share more features than the stock here. Okay, now I added this new point here. So like all these black points, this is our database. We have our data indexed there, and now we make a search query, means we get a new image we've never seen before, encoded with our encoder into this lower dimensional vector representation. And now we can do a nearest neighbor search. And we say like, there's a distance, we would say this would be a hit, and everything beyond, it's too dissimilar, so we would not consider it to be a relevant search result. And then based on the distance, we could say, this is the first search result because it's really close, and the second search result, and there's a third search result. And yeah, this cat probably, because it has the same pose, it's in there. So this example is made up, but the others were real. And yeah, this sad cat is not in there. So thumbs up, maybe next time it works, being part of the search result. Okay, so we did quite some progress. We have pre-trained model. Then we get our low-dimensional understanding, can calculate our distances, and retrieve the relevant search results. So we're done with the theory part here. But now we go more to practical application. And yeah, we had a client, and they have 500K PowerPoint slides, and they want to index all of them and make them searchable, reuse graphics they already used for other projects to build up new PowerPoint slides easier, finding relevant topics. So if you have 500K PowerPoint slides, you probably don't need to create another one. You can actually reuse what you have. And the Jina solution, it works like this. We always build an index flow and a search flow. So we have an index time where we put everything into our vector database, and then we have query time where we actually serve queries and respond to search requests. And the index flow, index flow works like this. We insert the PDFs, then we have an OCR component. Sometimes there's some text on pictures. Sometimes it's written in the PDF directly. It gets all of these text chunks out, all of the images, and puts them into image encoder or the related text encoder. These can be different pre-trained text models, and so we usually just try out what works best for this use case and that. So we have like 20 text models we can use, and it just depends on the data then which one to use. So after this step, we get here these vectors, and we put them into these vector database. One thing to mention is, of course, they have a different latent space. So like this image encoder is embedding it to another latent space than this one, at least in our example. So we have to also store them in different index databases. So first you can think of this image index and text index just as a database containing all the vectors, all the extracted features. It's a bit more. So it also makes sure that when searching on this database, it's performant, and it doesn't have to compare with each of the vector calculating the distance to do the brute force algorithms. It's a bit smarter, but you can think of a database. And yeah, the search flow. It uses the same components, but it's a different Jina object, different flow, which now not only takes PDFs as input, but user can make a text query, also provide just an image, or provide a full document, and then get similar results accordingly. Like, yeah, this has to go to OCR. This has not a big change here. Also, the image encoder, text encoder, it's the same. The whole pre-processing has to be also the same, because otherwise you have a gap between indexing and search, and your search results would be quite bad. And now we do here on this index database, we do our nearest neighbor search, retrieve the results, and then there's a final ranker component deciding based on all the distances of all the different parts of the documents, puzzle everything together, and providing the final score for all the documents so they can be retrieved in sorted order. Okay, one more thing about our cloud architecture. So it's getting more and more practical here. For this client, we used Google Cloud Platform, pushing commits to our Google Cloud Platform repository, which triggers cloud build. It's a continuous delivery system. It runs batch job, where here our index is created in this deep learning VM with a powerful GPU. And yeah, it uses it gets all the data from this storage, from this bucket here, all the PDFs, and then also uses some caching, because when we run the flow with a different ranker, for instance, and there's so much pre-processing, the OCR, for instance, which is also costly, we would have to do it again and again. So we do some caching here, which is outside of Jina, but this is exactly what we do in the solution engineering. If there's a recurring pattern, and I guess caching will be one of these, then in long term, we will introduce it into the core. And yeah, this is the whole purpose actually of what we're doing. And after calculating all the fancy, building up the fancy index structure, which makes efficient search and nearest neighbor search, it stores this gold nugget into another cloud storage. And there it waits a bit until the new API is deployed in Kubernetes. And here runs the search flow. And search flow doesn't have to do much of initialization. It gets the delicious index from the storage and then can serve search queries. It's serving search queries from the front end. Yeah, so this is like a classical implementation and how this, yeah, everything works. So front end gets deployed and runs search queries and everything I explained so far. Here are some, so now I can lean back a bit again, and here's some search results. For instance, here the query was robots will take over the world. I don't know who came up with this one. But yeah, the results are, there's not science fiction, the robots are coming, which was a good signal for us that the model actually gets more context. Of course, like with traditional search, you could match robots. So this is not an advantage for neurosearch, but are coming and take over the world. I think this would be very hard to, for traditional methods to make synonyms and similar phrases and hard code this. Oof, better to use neurosearch. By the way, the neurosearch, it's always good to combine with traditional search. And like I think in most real-world applications, it's also done like this. So yeah, some other funny examples as well. And then if we put in garbage, then we also get some garbage, something which was incorrectly detected by the OCR. It's really good actually to see if these are the nearest neighbors. It means like the model detects this is nonsense, and it has a close similarity to other things which are also nonsense. And this can be very efficient to clean your data by finding one nonsense document and deleting the nearest neighbors. Then we search by image, getting similar skylines here. This is really useful. When you ever work on a PowerPoint presentation, you need some inspiration. You think like, this graphic, I need some circular thing, but maybe not in this style. And you run a search query and get also circular visualizations, but in a bit of different style. And here I found this interesting because it takes over the style from this document. You can find illustrations which have a similar style. And of course, we were unstoppable. We also built a 3D visualization. Yeah, the latent space is, in this case, it's 1000 dimensional, and we used a dimensionality reduction method, UMAP, to reduce it to 3D space so that you can immediately see like these documents. They look quite similar, and maybe there's also something then interesting to investigate why this is the case, or you just want to find similar documents. So you can navigate through the latent space and discover your data that way. But yeah, this is just a solution we built. So this is not totally Jina related, but the client wanted to have this. So to summarize everything, Jina is a framework for neurosearch. You can focus on your search solution and don't have to think about the infrastructure. Just focus on what you're building. And this is quite a relief, actually. And then, like more from our perspective, when building a framework, it's necessary to build solutions yourself so that you really know what you're building there, really know that it's useful for and practically applicable also for other framework developers as a takeaway. Okay, now we come to this important question of our talk. Why does feel amazed by rhyme with Jina AI? At least for rappers it rhymes. And the answer is because Jina AI also rhymes with he explained why. And yeah, whatever. Anyways, here's the happy cat as promised. And I think we made it. Thanks all of you for your attention.
Thank you very much, Florian.